This protocol, Enhanced Interior Gateway Routing Protocol. This is by Cisco. It's a routing protocol given by Cisco. But Cisco has tried to make it as an open standard. Right now it is not a proprietary one. Anyone can use it. But it is designed by Cisco. Enhanced Interior Gateway Routing Protocol, EIGRP. Now the specialty of this protocol is you can form group and share routes only between those group members. We call it as an autonomous system number. That number helps to group routers, and only those routers that are in group will form neighbor, and only between those neighbors the routes will be distributed. There is another special thing about this protocol. This protocol can support both equal cost as well as unequal cost load balancing. See, every protocol except BGP, every protocol will do equal cost load balancing. What does that mean? It means when we have multiple paths to reach a destination with same cost. When we have multiple paths to reach a destination with same cost, all paths can be used. Up to 32 paths. You can have in a routing table for a destination, provided the metric of all paths should be same. We call it as equal cost load balancing. This is supported by RIP, EIGRP, OSPF, ISIs. But what other protocol cannot do, which EIGRP can do, is EIGRP can also do load sharing across unequal cost load balancing. So, first point we learned, EIGRP helps to form a group using autonomous system number. Second point we have learned, EIGRP supports both equal cost as well as unequal cost load balancing. Thirdly, EIGRP will not send periodic update. No periodic update in EIGRP. If you take RIP sends periodic update. Whether there is a change in the topology or not, EIGRP will send updates RIP will send updates every 30 seconds. That is periodic update. Every time interval, every 30 seconds, EIGRP will send, RIP will send updates. Whereas EIGRP sends update only when there is a change. EIGRP will never send a periodic update. Why? Periodic update is bad. Why it is bad? See, if there is a change and when you send the change, then it is good. But when there is no change in the topology, sending the update repeatedly, the same update every 30 seconds, will unnecessarily utilize the bandwidth as well as the processor of the receiving router. It's unnecessary, unwanted disturbance caused. EIGRP will never do that. EIGRP will send only the changes when the change occurs. EIGRP will send the change as an incremental and triggered update. EIGRP will simply send the change alone immediately. That's the meaning. Incremental and triggered update. So as soon as the change happens, the change will be published to everyone immediately, which is good because you don't unnecessarily utilize the bandwidth or the processor. Thirdly, I think this is the fourth point I'm going to say. See, first point was EIGRP uses autonomous system to group routers. Second point, it supports unequal cost load balancing. Third point was no periodic update, only incremental and triggered update. Fourth point is EIGRP is a classless routing protocol which supports VLSM, variable length subnet mask. So subnetted networks EIGRP can handle. A classful protocol cannot handle subnetted networks. Classful protocol cannot handle VLSM, variable length subnet mask. EIGRP is a classless routing protocol which can support VLSM. Next, EIGRP is very simple to configure both in a WAN as well as in a LAN environment. In a LAN, in a WAN, the configuration commands are same, easy to configure. Next, EIGRP supports multiple network layer protocol. What does it mean? Layer 3 is what we call it as network layer. In OSI reference model, we have layer 3. And layer 3 is what we call it as network layer. In network layer, we have a protocol called IP. No, we have IP. IP works in network layer. Like IP, we also have another protocol called IPX, Apple Talk. These are all different network layer protocol. See, this EIGRP that we are learning is a routing protocol that works for IP network. But what if there is a network with IPX, no IP address, no IP? They use IPX. That's a different protocol, different encapsulation. Do we have a routing protocol for IPX? Yes, EIGRP is a routing protocol for IPX network, Apple Talk network. That's EIGRP, Apple Talk, IPX. They all use EIGRP. You have a EIGRP module which supports IP as well as IPX as well as Apple Talk. But who cares? No one uses IPX and Apple Talk as per my knowledge. I don't know, maybe some may use, but I've never seen. I see only IP network. But there are some old networks, there may be some old network which may run IPX. But I don't know how they can participate with the rest of the world. They should be isolated because everyone in the world uses IP. Anyway, what I'm coming to say is even for IPX and AppleTalk, you got support from EIGRP. This is all something unique which you cannot find in other protocols.
So, Jay, I got a question.
Yes, please.
Did you say, and I've never seen IPX, that's the first time you've been here, but I saw about GRE, the generic routing encapsulation. So,
yes.
You're saying that there's tunneling, right? It adds another tunnel.
Yes.
Would it be in comparison to like VPN? I remember you mentioned that yesterday about
yeah.
creating a tunnel.
Correct. GRE is also a VPN.
Okay. All right. So I'm understanding correctly.
Yeah. GRE is also a VPN. Any encapsulation is a VPN. If we encapsulate a layer 3 packet with another layer 3 header, then it's a layer 3 VPN. If I encapsulate a layer 2 packet with a layer 3 packet with a layer 2, then it is a layer 2 VPN. Example, VPLS. VPLS is a layer 2 VPN. Yeah. So GRE is a layer 3 VPN. Yeah. Any other question in this topic, EIGRP?
No. I have some notes that I'm sticking down, but no, I understand a whole lot better than before.
Okay. So I have never seen one like that. So if you will have an IPX network, we have support from EIGRP. So EIGRP can be a routing protocol even in AppleTalk network, IPX network. So few points which I have not covered, which you see here, are manual summarization at any point. What is that? What does that mean, manual summarization at any point? If you take OSPF, you can summarize only on ABR router and ASBR router. Whereas in EIGRP, you can summarize on any router. You can use auto summarization, or you can also use interface level or interface based interface level summarization, which is what we call it as manual summarization. More detailed information about these topics are coming later. I'm just giving you an introduction to EIGRP. I'm just trying to picture how EIGRP is better or how EIGRP is different from other protocols. You cannot do manual summarization at any point in other protocols. You can do only in EIGRP. And I also covered this point. Supports both equal cost as well as unequal cost load balancing. Also I covered this point. Easy configuration for both LAN and WAN. And then I was also saying the partial update means, triggered update. Only the change that happens will be sent instantly. And then I also said it's a classless routing protocol which supports VLSM. If it supports VLSM, it can support disk convergence network. It supports multiple network layer protocol like IP, IPX, AppleTalk. Flexible network design, meaning you are not limited to any size. EIGRP can fit into a small network or a large network with many routers. It can fit anywhere. So flexible network design. Next is EIGRP will not use broadcast for anything. It won't use broadcast for sending update or hello packets. It only uses multicast and if needed unicast. So which is very good actually. If I want to send to all EIGRP routers, I use multicast. If I want to send to a particular neighbor some updates, then I use unicast. So unicast and multicast instead of broadcast. Now I have 3 more points to be covered. So let me start from here. 100% loop-free classless routing. See, every protocol guarantees loop-free network. Every protocol has got its own ways to guarantee this. How EIGRP can guarantee 100% loop-free classless routing? By using an algorithm called diffusing update algorithm, dual. Dual algorithm is what the algorithm EIGRP uses for best path selection. For best path calculation, an algorithm called dual, diffusing update algorithm, dual. So if you check the routing table, EIGRP routes will be seen as D. Why EIGRP routes are seen as D in the routing table? D 70000 via blah blah fast internet 0/0. Why it shows D? Because of the algorithm dual. EIGRP uses dual algorithm. How the RIP routes are shown in the routing table? R. How BGP routes are shown in the routing table? B. How OSPF routes are shown in the routing table? O. How EIGRP routes are shown in the routing table? Not E. It is D. Dual. Dual. The reason is EIGRP path selection is using this algorithm called dual. That's why it is D. Dual. Dual algorithm guarantees 100% loop-free classless routing. So when a path is selected, the path needs to be a loop-free. So dual algorithm picks the path which will never have a loop, which will not form loop. Next, EIGRP is very fast in convergence. You know why? This protocol can maintain a backup path. EIGRP maintains a primary as well as the backup path. The backup path will be in the topology table. The primary path, the best path, will be seen both in the routing table and the topology table. When the primary path goes down, the backup path will be promoted as primary and will be seen in the routing table. So when the primary path is available, the backup path won't be there in the routing table. Backup path will stay in the topology table. Only when the primary path goes down, the backup path is promoted to primary and then brought into the routing table. So EIGRP is very fast in convergence because it has got the backup path for use if the primary path goes down. You can simply swap the gateway, that's all. Earlier it was going via that gateway, but that gateway failed, so it pushes the packet via this gateway. Fast in convergence. There is no much packet loss. Yes, please.
Does it continue with the session of path. So primary path goes down. Second path takes over as the primary path. Is there a third path that is identified as a secondary path as well? Or
Yeah.
how's that?
So if you have multiple paths, let's say you can have up to 32 paths. Now, the path with the lowest metric will be the primary path. The second lowest will be the backup. All others are also backup, but when the primary goes down, the second lowest in metric path will be promoted as primary, and the third path will remain as backup. Did I answer your question?
Yeah, it does. When you said it supports multiple paths. Okay.
Yeah.
Up to what, 32 paths?
Yeah.
Each destination?
Yeah, for each destination you may have up to 32 paths, but by default only 4. Only 4
Okay.
paths, but we can go and increase by using a command called max path. Using a max path, you can specify how many paths you need. For example, if I don't want multiple paths, I want only one path, you can say max path is 1. But what is the default max path? 4. You can increment up to 32. So when we have like 10 routes with various metrics, the one with the lowest metric is going to be the primary. The others are going to be backup. Alright. And when the primary goes down, the second lowest is now the lowest among all. That becomes the primary. Yeah, any question?
No, I'm good. After this.
Right, thank you. So, now one last point that we have to cover in this page is EIGRP is an advanced distance vector protocol. Why? EIGRP advertises the metric and the direction, but the metric it advertises is not a complete metric. It's only an advertised distance, means partial metric. Based on the partial metric, the complete path metric is calculated. We'll be learning more on this point when we go further later in our following classes. So, EIGRP is not a hybrid protocol. In CCNA level, they will teach like EIGRP hybrid protocol, which is not really true. It's an advanced distance vector protocol. Vector means what? Direction. Distance is metric. So it calculates the metric in a very advanced level using this dual algorithm based on the bandwidth and delay. The metric, the distance is calculated for each direction. That is why it is called as distance vector protocol advanced. EIGRP is an advanced distance vector protocol. So these are the points that EIGRP has got special features. EIGRP special features. Next. Now EIGRP always discovers the neighbor. Neighbor discovery. You no need to configure manually neighbors. EIGRP can dynamically discover the neighbor if the neighbor is in the same autonomous system. Not only same autonomous system, the neighbor also should be in same subnet. Same autonomous system, same subnet. If yes, EIGRP can form neighbor. But neighbor need to be directly connected. So neighbors are discovered dynamically. How? By sending hello packets. So when two routers send a hello packet, when that autonomous system number is same between them, and when they both share a common subnet, they both will agree to form neighbor. But to form neighbor, what is helping? Hello packets. When a router sends hello, it will say, hey, I'm coming from autonomous system 500 and my IP address is 10.0.0.0/8. And the neighbor will see, okay, I'm also in 10.0.0/8. I'm also in autonomous system 500, so let us form neighbor. Let's agree as a neighbor. So it is the hello packet that helps to discover neighbor. Like human being, we say hello when we are trying to form neighbor. The very first word that we say is hello. Likewise, EIGRP uses hello packets. It's a tiny packet which is advertising the IP address of the router from where the advertisement is sent, and the autonomous system from where the packet is coming, so on. This is sent every 5 seconds. Hello packets are sent every 5 seconds. And with the hello packet, neighbors, they discover each other and they form neighborship. After they form neighborship, they share their database, and now whatever the router A knows, even router B also knows it, and whatever B knows, A also knows it, because they share the update when they form neighbor. Not only that, they keep sending hello every 5 seconds to maintain the neighbor. So not only discovery, even maintenance. How I maintain the neighbor? How do I know the neighbor is there? Because the neighbor is sending hello every 5 seconds, I maintain him. I make sure that neighbor is there in my neighbor list. Not only that, if a neighbor goes down and comes back, it's the same hello packet that helps to recover. So EIGRP uses hello packets. Next, EIGRP uses a protocol called RTP, Reliable Transport Protocol. This is not a real-time protocol This is not real-time protocol that we use in voice. Sorry. This is Reliable Transport Protocol, which is EIGRP's own protocol, Cisco's own protocol. This is like a TCP. How TCP guarantees the delivery of packets. TCP sends a sync packet, sync acknowledgement, a three-way handshake. Likewise, between EIGRP routers, the connection is established with a protocol called RTP, Reliable Transport Protocol. So with this RTP only, we get guaranteed order delivery of all EIGRP packets to the neighbor. Next is, as I said earlier, it is the responsibility of a dual algorithm to select the low-cost path, which is called as best path, and install the best path into the routing table for each destination. And this path also need to be loop-free path. Who takes responsibility? It's the dual algorithm. And as I said earlier, EIGRP has got For every network layer protocol, there is a separate module. For example, for IP, you got a separate module of EIGRP. AppleTalk, another module. Novel network, which is IPX, there is another module. Each protocol has got its own EIGRP module and operates independently of any of other that may be running. Now EIGRP maintains three tables. One is neighbor table, another one is topology table, another one is routing table. Right? So neighbor table will have established neighbor, directly connected established neighbor, the neighbor who is in same subnet and same autonomous system number. In the topology table, there will be two paths. One is successor route, which is called as primary route, and the backup route we call as feasible successor. So for each destination, in the topology table, you will have a successor as well as a feasible successor route in the topology table. I would like to go more deep into this in our next class. As of now, I just take these two terminologies. Successor means primary, feasible successor means backup. For every destination, topology table will maintain the primary and the backup. As I said earlier, you can have up to 32 if they satisfy something called feasibility condition, which we'll be seeing later in our next class. So next is the routing table. The routing table will have the best route. Now you see this picture. From C, we can go via E0. If you go via E0, you will go via A. A is the gateway, next hop, in order to reach this network. If you go via E1, B is the next hop. You can reach the same destination. I told you in the topology table you will have the best, see only 2000, and also the second best, the backup, which is via E1. This is the backup. This is the primary. The primary path is called as successor routes. The primary is called as successor route. The backup is called as feasible successor route. So the routing table will have only the successor route. You see, the route whose metric is lower is what we see in the routing table for the destination 10.1.1.0. But this is over. I have a lot of other things to teach. I want to teach it when we are fresh. In tomorrow, the first topic will be understanding this terminology. So we'll come back here. Now, EIGRP, yes, please.
No, I said okay. No. Go ahead.
EIGRP has got 5 different types of packets. One, the hello packet, which is tiny packet which helps to discover neighbor, maintain the neighbor, recover the neighbor, and which is sent every 5 seconds. Updates are sent whenever there is a change. Queries are sent if the primary path is lost and there is no backup path. Repeating again. Query packets are sent by EIGRP if primary path went down and there is no backup path. So it will start querying every other neighbor about the destination. That is query packets. Asking the neighbor about route information for a destination which the route is lost. Now, if any router knows the answer, it will be reply packet. Reply is nothing but the response to the query about the routing information. Now, for update, for query, for reply, there will be an acknowledgement sent. So these are the 5 different types of packets in EIGRP. Hello packets, update packets, query packet, reply packet, and acknowledgement. Query we understand, acknowledgement we understand, hello we understand. Update and reply are not the same. Update is the routing update sent. No one needs to ask. When there is a new update, we send. That is update packet. But the reply is a response to the query is reply. Without query, there is no reply. But there can be an update without any query. Alright. So this is about discovery, which we will be seeing again in the next class. Now this one I want to cover today. EIGRP and EIGRP. EIGRP is the older version of EIGRP. EIGRP, you see, it's if you remove E from there, it's EIGRP. Yes, Cisco initially came up with EIGRP. EIGRP uses 24 bits for metric calculation, whereas EIGRP uses 32-bit for metric calculation. So how many times bigger? EIGRP is 256 times bigger because 8-bit extra. Here it is 24-bit, here it is 8-bit extra, 32-bit. That is why here it is written, if you multiply EIGRP metric with 256, if you multiply EIGRP metric with 256, you will get EIGRP metric. Anyway, is it important? No, it's not at all important. Why? We don't have EIGRP anymore. It's a very old protocol. After EIGRP, EIGRP slowly vanished. We don't have EIGRP. But these 5 metrics are common for both EIGRP and EIGRP. Bandwidth, delay, reliability, load, and MTU. The 5 metrics of EIGRP are bandwidth, delay, load, reliability, and MTU. Though I am showing you 5, actually bandwidth and delay is what focused. These 3 are not considered. Why not considered? I'll explain you in detail in coming days, but they are not considered because reliability and load are variable. Much detail I'll give you when we sit for another class on the same chapter. So as I said, the default metric of EIGRP is slowest link bandwidth plus sum of delay. The other things are not really necessary. Alright, so I think only few things I'm skipping for tomorrow. We have finished this chapter. So this one is like compatibility between EIGRP and EIGRP. As I told you, EIGRP uses 32-bit, EIGRP uses 24-bit. So if you want to convert EIGRP into EIGRP, you divide by 256. If you want to convert from EIGRP to EIGRP, you multiply it by 256. They are compatible if autonomous system number is same. They are auto-compatible, backward compatible. You don't need to do anything. All these things will happen automatically. But this topic is not important because we don't have a protocol EIGRP now. So, next. In this page we are going to cover again tomorrow in detail. That's why I just jumped this page. This page has got something to do with this page. See, metric of EIGRP is slowest link bandwidth plus sum of delay. If you see this picture here, for A to reach D, this direction, the slowest link is this one, 64 kilobits, whereas this one is 1500 kilobits. T1 means 1500, means 1.5 mega. So the slowest link bandwidth is what the bandwidth via ABCD plus sum of delay, means you need to add 2000, this 2000, this 2000. Right. So the other parts we will see in our next class, and this is also the one which I skipped, and then this page. So in our next class we will discuss on the these are very important, that's why I keep it for next class. This one, and then this one, and then this one, and then we will get into second chapter once we finish this chapters. Yep, so we are going to stop here. Do you have any question for me based on what we covered today?
No, just making sure I understood the successor route. Primary feasible successor is the secondary. Then you said that IGRP is making non-existent now. Because I think you said the primary metric used is the bandwidth and delay.
Yep.
Reliability loading the MTU is not considered.
Yep.
Yeah.
Wonderful.
Okay.
So the reason why we don't consider reliability load and MTU is reliability and loads are variables, and bandwidth and delay, they are already considered, which are constant. So we do not want to have another constant MTU. Again, I am going to repeat those things in much clarity in our next class, more detail. Yeah. So thank you so much for joining today. See you tomorrow, same time. Take care.
Okay. Thanks.
You're welcome. Thank you.